In this video, we are going to talk about the coding aspects involved in a smart farming warehouse project. We'll start with the Arduino IDE, then move on to the AWS IoT configurations, and finally our web application. So without any further delay, let's start with Arduino. The first aspect in programming an ESP32 is to know how we can read the values from sensors that are attached to different pins on ESP32. So here we have defined the constants for the pins on ESP32. We'll be connecting the sensors and relay to. We have created two methods, get moisture percentage and get light percentage, which will convert the raw values from sensors and return them into human readable format. We are calling the analog read function to get the sensor values. The reading frequency is essentially the same as the frequency of the loop function, which we are setting using a delay function. Once we read the values, we publish them to AWS IoT using our publish method. In order to do that, we need to configure the Wi-Fi and AWS endpoints and necessary certificates as shown in this code right here to establish a secure connection. In our case, all that configuration is done in secrets.h file. The values are empty right now because that's sensitive information. Once that is done, we have to create a JSON in the format accepted by AWS IoT Thing Shadow, and then we can securely publish a message using this client.publish method as displayed over here. Regarding the relay, we have configured our threshold in the loop function right here. So if the moisture sensor value is greater than 40, the high signal is sent, which turns on the green light on the relay as shown in the previous video. Once the threshold is met, our duty cycle comes into play and it puts the ESP into deep sleep for a configurable amount of time in order to reduce the battery consumption. This is done using ESP Deep Sleep Start API as highlighted here, and the sleep time is configured as shown here. Now we'll be moving on to the AWS console to show IoT configuration. This is our AWS console. We'll navigate to IoT core service and click on manage. Here, as you can see, we have created a thing called ESP32, which we are using to interact with our registered devices using MQTT endpoint URLs as shown here. This interaction takes place using the thing shadow. The next step involves creation of a rule, which is send data to Dynamo in our case, to accept the published data on the thing shadow and insert the values into the DynamoDB table called sensor data that we created. Once the data starts flowing into the DynamoDB, we created a Lambda function called testIoT.js to fetch all the values from the table and interfaced it using API gateway to create a REST endpoint that is used to fetch the data in our web application. Moving on to our web application, we have created a mobile application for end user that displays real-time moisture, light and temperature values from the sensors as shown in the previous video. The application is connected to AWS IoT to fetch real-time shadow updates using MQTT. AWS IoT Device SDK is used to establish connection with AWS IoT using Cognito Identity Pool, which is also an AWS service. Here, we are configuring our thing shadow that is used to receive the shadow updates. This happens when we register our ESP32 thing as shown in the code here. Once the shadow is successfully registered, all the changes to the shadow are captured in the delta function as shown here. Once this delta function is invoked, we extract the moisture and light values from the state object and update our HTML DOM element. This part essentially shows the real-time values from our sensors. As soon as the connection is established with AWS IoT using AWS IoT Device SDK, we call getDBData function, which makes an HTTP call to REST endpoint URL that we showed earlier to fetch the historical data that is stored in the DynamoDB. to identify the past values. So this covers all the coding aspects of our project. This was a basic setup for our demo. The connections that we displayed earlier are all wired, but the future work will involve other low power wireless communication channels like LoRa or Zigbee. Also, there are a few more aspects like scalability, data encryption, and data caching server that needs to be addressed while developing an IoT solution for large scale projects. Thank you.